James Webb Space Telescope found the most distant star ever known. The space industry is speechless. A star almost 12.9 billion years old has been discovered by the James Webb Space Telescope. It is the most distant object known to humanity and Earth. Science experts call it amazing. A significant milestone has been reached in the history of astronomy. This is a considerable achievement, and one can only imagine how things were back in 1998 when the James Webb Space Telescope was being built. Things have changed with much more advanced technology, improved efficiency in scientific research, and an increase in funding. Still, this momentous discovery is a testament of how far humanity has come since then. The James Webb Space Telescope saw the beginning of a new era in interstellar astronomy. The infrared observatory has seen many candidate galaxies that don't fit with the Big Bang Theory or our model of how galaxies evolve. Webb nowadays is working on equipment for Arendelle, the furthest star. This Arendelle is 12.9 billion years away from us by light. Astrophysicists have searched for Arendelle's star for more than 100 years. They think it might be a rare group of stars. But how did scientists discover a single star so far away from the rest of the universe? What really is unique about Arendelle from those other stars? How do the recent discoveries of James Webb of Arendelle contradict theories of stellar evolution? How far do you have to go? Up to 12.9 billion light years separate us from Arendelle. But it is now 28 billion light years away, which is approximately how far the universe has grown. Therefore, we're looking for the star in the same place it was 12.9 billion years ago. This indicates that Arendelle is 8.2 billion years older than both the Sun and the planet Earth. Still, the minor things observed in these situations are star clusters in faraway galaxies. But Arendelle is the very first star to be so far away from everything else. What kind of telescope saw it? The Broken Space Telescope was used to guess where the star was. Hubble first observed the star's parent galaxy, shown through a group in its foreground by the force of gravity. Significant astronomical things like galaxy clusters distort the space-time fabric around them. Due to this, the light from international celestial bodies bends before it gets close to the large objects, which requires a certain alignment. The brightness from different stars can be multiplied by the foreground cluster 1,000 times. The brightness from different stars can be multiplied by the foreground cluster 1,000 times. Because of this, the background galaxy that could be seen from Arendelle looked like an arc. Astrophysicists call this the sunrise arc. But the squad could see a point of light sitting on the warped galaxy's rim. Black holes cause energizing activities like tidal interruption, exploding stars, and novas, which are used as light sources in galaxies far away. They talk about the changes in luminance that happens over time. Still, Hubble's observation indicated that an entity's luminous remains could begin to appear in about 3.5 years. Astrophysicists have concluded that this represents the bright star gravity of sunrise arc that its wavelength has bent. Hubble can only tell us a few things about the faraway star. Astrophysicists use the James Webb Space Telescope to investigate the characteristics of Arendelle because of this. It was led by Dr. Brian Wells of Johns Hopkins University. In March 2022, he and his squad used the Hubble Space Telescope information in their research study to find the star. Experts looked at new photos of Arendelle taken by Webb's NIR instruments. The images include a variety of wavelengths from 0.8 to 5 microns. Arendelle's investigation turned up 8 different Webb filters, and each one had an exposure of more than 30 minutes. Okay, what is some significant stuff? With the new info from James Webb Space Telescope, you can note 3 essential things. The redshift of a star is the first deep space entity that can be seen with a telescope. Redshift gives you an idea of how far away it is. Redshift displays a number that has no units. Z is equal to 0, which shows the current time, and as the valuation gets higher, so do the distance, and the time it takes to look back. Based on the observation from the new Webb, Arendelle is at 6.2 redshift. The number stays the same with records from the Hubble telescope, which arrived early in 2022. This made Arendelle the star with the maximum redshift. You understand that the most crucial information about Arendelle is the amount of energy or biometric light the star gives off on the electromagnetic spectrum. The Webb data indicates that Arendelle can't become a low-mass star, an exoplanet that floats in space, or a star that bends gravity. Instead, the analysis shows that the effective surface temperature of this B-type is between 13,000 and 16,000 Kelvin. There are 7 different kinds of stars in the universe, based on their surface warming O, B, A, F, G, K, and M. There is a traditional way to remember the order. The question is how to figure out the total illumination of Earendel, which is between 6,000 and 1 million times the luminance of the Sun. It proves that if Arendelle is a single star, it should have about 40 times as much mass as the Sun. If not, the light could come from 2 stars with 30 solar masses or 5 stars with 20 solar masses. Researchers noted in their article that a solution of a single star might only describe the schemes of spectral energy distribution, and because of this, Arendelle might have a way of making more than 1 star. Massive stars in the visible universe have mates and frequently have more than one. The elementary companions in the 2 tertiary mates can be as far away as 20 astronomical units. The purpose is that Arendelle has companion stars, which the James Webb Telescope can't see due to the resolution power. The star is 1 million times much brighter than the Sun, which is also a problem. It will pass the high definition limit, or the Humphreys-Davison note. The empirical luminance limit, also known as the HD limit, is something that can't be seen in the star, at least in our part of the universe. But if Arendelle is about a single star that is a million times brighter than the Sun, you will need to rethink the HD limit and add new limits. Arendelle's finding is important because it could be the first time astrophysicists have seen inhabitants 3 star, which is something they have been looking for a long time. Population 3 stars are made of 2 chemical constituents, helium and hydrogen. The first ever generation of stars demonstrates that the population of 3 stars has small amounts of metals, followed by a tiny metallist. The first ever generation of stars demonstrates that the population of 3 stars has small amounts of metals, followed by a tiny metallist. In astronomy, any component other than helium and hydrogen is considered a metal. Think that most of the population 3 have melted, and the ones left are hard to spot and extremely dim. It would be almost unrealistic to observe them in the sky, and most of these candidates are composed of gravitationally lensed galaxies. Astrophysicists do think Arendelle will grow very big in the future. The next time the James Webb Space Telescope will look at Arendelle from space will be in December of 2022. If you can evaluate Arendelle's brightness well, you can figure out what phase and category it is in its lifespan. Astrophysicists can hope for dawn. It rarely happens. Astronomy's holy grail was to find the first galaxies and stars. When we see the first generation of stars, we will be capable of comprehending how they form and taking note of the forecasts made by the model for the Big Bang. Furthermore, trying to find them is like finding where they came from, just like Richard Feynman said. Astronomy's most fantastic observation is that stars are made of the same kind of atoms as Earth. So that's it for now. I hope this video was as informative as always. If you liked this video, hit the like button and watch the other video as well. To know more details, and smash the subscribe button for more future updates. Let's meet in the next video. Thank you for watching, and with those words, I'm out.